so... No, it's good. Just keep being there. I'm going to cut this little... Kia ora team, my name's Ben and this is...
Tino.
Alright, and he's going to talk me through the...
Force velocity relationship.
Good. So during a...
Concentric contraction.
As the...
Velocity increase.
The force...
Decrease.
Good. And why is that?
The cycling rate of myosin.
Good. The cycling rate of myosin. So if we remember, C for concentric, C for cycling rate. Velocity increases, force decreases. Then on the other side of our relationship, we've got the
eccentric contraction.
And during an eccentric contraction, as our velocity
increase,
our force
increase.
Good. Why is that?
Elastic components.
Good. So if we think E for eccentric, E for elastic. So now we're going to have a look at why that is. All right, cut. These beautiful human beings are
Myosin.
Myosin, because myosin is one of the protein myofilaments in the muscle that contracts, and myosin is thick and
dark.
So under a microscope you can't see through it, whereas the actin is
Thin and light.
Thin and light. So I'm going to be the actin. Actin stretches out over the myosin, and myosin has...
Myosin heads.
Good, myosin heads. So give us your heads. Actin's going to stretch across here. So during a concentric contraction, what does the myosin do? Shortens. It pulls on the actin. Good. So as it pulls, we generate tension. Once it's pulled as far as it can, then to pull again, what's going to happen? Good. Some of the myosin heads will have to let go, and as they do, what happens to the force? Decreases. Good. And then they let go, grab again, and pull. Let go, grab again, and pull. What's that called?
Cycling rate.
Cycling rate. As the contraction goes faster, so as the velocity increases, more myosin heads are going to drop, and as the cycling rate goes faster, so drop, 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 now what happens to the tension?
Decrease. Drop.
Yeah. So during a concentric contraction, as velocity increases, force
decreases.
Because of the
Cycling rate.
Gorgeous. We still good, myosin? Alright, so as myosin contracts, and they hold, that's an isometric contraction. So an isometric contraction is the most that the myosin can contribute to the force. If for some reason more weight is added to the bar that we're lifting, then we're going to start doing an eccentric contraction. So if myosin holds and the bar starts to lower, we're going to get more force, but it's not because of myosin, it's because of the elastic element. So our epimyosin, endomyosin, perimyosin, sarcolemma, and the tendon stretches, and as it stretches, it's going to generate more force. So during an eccentric contraction, as the velocity
increases,
the force
increases.
due to the
Elastic component.
boom!